Hello everyone, my name is Volterra. I'm a developer for Krita. I'm also a participant in the 2016 Google Summer of Code program. And my project was making Krita ready for wide-gamut editing. And it's finished, it's merged into master now. So I wanted to show you off what it exactly entailed. I have here Krita 3.0.2 alpha, which is the current master. It has all the new features we've been making over the past few weeks that couldn't fit in 3.0.1. It's also pretty unstable right now, so if something happens then you know what's going on. Now, when hearing my project name, making Krita ready for wide-gamut editing, one half of you will go like, huh, what's that? And the other half of you will go like, huh, but Krita was already capable of wide-gamut editing, so what exactly did you do? Before I can answer that, we're just going to first make a new file, because I think it might be best to show you the first thing that you will notice. And the first thing that you will notice is that if we summon the pop-up palette, it looks slightly differently. It's not turning around anymore. Yeah, I don't know why that went red just now. It's not turning around anymore. Very strange. And what exactly I did is, might also be more visible here. If I click here, you see the same selector, but it looks slightly differently, doesn't it? And that's actually because this selector is a complete re-implementation of this thing, and which allows me to put it in the pop-up palette. And you might think, like, well, how is that any interesting? I mean, we had a perfectly fine triangle over here. Well, we can now have a square. And what I actually did is a bit more difficult to explain, and it's also something that I will need to explain. That is just very difficult to explain to even most people who know Krita very well, and that's because it relates to color management. So I'm going to make a new file, and I'm going to go to the color space browser. So if you know anything about color management, then you might recognize this, and if you don't, I'm just going to explain it now. This is the color space browser. This is something I implemented last year, and it shows information about the color profiles that Krita carries. And this lovely little thing here is a CA XY wide-gamut, which shows the full spectral locus of colors that humans can see. And this triangle inside it is the sRGB space, also known as screen RGB, and it is a standard for what consumer screens should be having. This is what most laptop screens, including the one you own, have. This is the maximum colors that they can show compared to the full human spectral locus, that's full human color vision. We can have different sizes. We can have really big ones that cover the whole thing, and we can have other really big ones and regularly big ones, and anyway, so these are all a lot bigger than the sRGB space that we have here. But the thing is, because I can show you how these points compare to the sRGB space, that means that the computer is able to get those points, right? And if the computer can get those points, it can do interpolation and can do maths on them. And that's basically what color management is. It is interpolating and converting and matching between these different color spaces. What is interesting, however, is that because this is a standard, and most applications that don't have color management can only they are implicitly only being able to select colors within this range, within this gamut that we call this. And Krita, despite being able to paint in these colors, these wide gamuts, for a long time couldn't actually select, or still can't select anything but the sRGB colors within this advanced color selector. And it has to do with the design being a bit, well, it just wasn't. I don't really know the history of this. I think it might have been developed before the wide-gamut editing was really proper, or anyway, it just can't select anything but sRGB colors. And it's also a bit of a complicated selector. So that's why I had to re-implement everything. So I'm just going to make like a small wide-gamut image. So hit create, and here we have our wide-gamut image. Nothing much different. It's 16-bit. But what it comes down to is that you see here this is like the most chromatic color I'm picking right now, and if I go here, this is like still the most chromatic color I'm picking. But if you go to the color selector I implemented, you'll notice that it is not the most chromatic color that I can pick. I can select much higher range of colors than is possible within this thing. And the same thing counts for the pop-up palette. It can select the full range of colors. Of course the colors look a bit glowy because of the color maths doing weird things here. There's more things implemented here, like for example you have your blue, green and red here. You have select previous color that you can use. You have the palette here. The palette is still kind of stuck in sRGB, but that mostly has to do with that we don't have a file format for storing these wide-gamut colors yet. We're working on it. One thing I noticed when I was working on this is that Krita can actually get palette names. So the hover over, now the tooltip shows now the palette name, and you can also use this thing here to select colors by name, and type in, for example, tomato and get red. The final thing here is this, which is ported from the cute color picker dialog. And what it normally does is that it allows you to pick colors from anywhere on the screen. Right? And it allows you to pick this color and this color. So we fully ported that because it had to fit within our system. But another thing we did is that it can tell the difference between the colors on different canvases, and it will color manage them. So these are 16-bit colors. These are 16-bit colors, and these are 8-bit colors, and we'll convert them to the 16-bit color of the active color selector. So people who know a bit about Krita's color management know that there's like one more thing that Krita can do, which is kind of cool, and people don't really talk a lot about it because they don't really understand what it is. But we support 16-bit float color spaces and 32-bit float. And that's a bit of weird color depth, because if I make a new image, if you go to a specific color selector, you'll notice that these colors go from 0 to 1. And that sort of still makes sense. But what probably isn't obvious about this is that they can get colors above 1. They can get 3 and they can get 5. And previously, if I right now type in 5 here and hit enter and then go to the next one, it will stay on 1. It will snap back to 1, and that's because it's tied to the lot management. So I turn on lot management, put open color IO, go to OCO environment. Now this is a look which was also implemented during the during the Google Summer of Codes. It can now read OCO looks, which are like I call it sort of like a filter, extra filter being done on top of the color management. But for example, I don't know what's going on here. Anyway, if you lower the exposure, then you'll notice that 1 is stuck here, which means if we go up, you can select the full color. You can select higher than 1, we can select 1.5 apparently. For our main color selector, this is also possible. We can select 1.5 and we can select 1.5 on all the possible things. But not just that, we can just also type 3 here and we'll select 3.02z02. This was previously just not possible. Yeah, there's also this thing. This will give you sRGB colors, so this is just for people who want to match colors via when they have like a character sheet prepared, and for a long time people just type down the web color, which is a hex code. So you can just type in the hex code here and it will give you an sRGB color. Let's see. Yeah, I think that's well, yeah, this is the big thing. You can lower the exposure, you can attack exposure, and this thing will be affected. The pop-up palette is of course, hello, again affected by it. I can select 2 now because our exposure is so low. Numerical input boxes also work here. So that works. I don't know where the thing isn't updating properly, but okay. So we can select these colors here, and it matches our advanced color selector, and we have like this thing, we can use all of this. So that's all very nice, but what if you want to have a smaller gamut? What if you don't want to have a wide gamut, but you have like a really tiny gamut? And when you and this is actually something that's quite common. This is this happens with CMYK, and this happens because real world pigments are able to show all these wide gamut colors. They're better at some colors than others, of course. They're a bit better at certain blues, but for example green is very difficult to reproduce properly in a CMYK thing. And what we usually said was that, okay, you want to show your image in CMYK, then I'm going to make you a lovely flower to demonstrate. Lovely flower with all these really bright colors on it. Well, if you want to see your image in CMYK, then convert your image to CMYK. And you see the difference here. The problem now is that we are currently in CMYK, so we are in this limited gamut that you can see here. And if we this is kind of a problem, because if you go back and we add a new layer and we press multiply, and we're going to put some blue here. We'll put a blue butterfly with a multiply layer here, and then we convert to CMYK. The butterfly is suddenly white, and this has to do with the fact that in RGB, when you have a higher value, it tries to represent the pixels of your screen becoming brighter and brighter, like the little lights that are in the screen itself. It tries to emulate them going brighter, so it says like, okay, the brightest you can have is white. In CMYK, on the other hand, we are using inks to paint on paper, so this is a white background on which we add more pigment, and so going high with the value makes it go black, or yeah, makes it go darker. There's more color, there's more pigment, and eventually if you mix all the colors together it becomes black. So the blending modes, which are effectively just arithmetics, they would be affected by this. They would show different colors in different color models. So so this is not actually a very good way to preview your RGB image in CMYK. Typically, what most programs have, if they have good color management, what they have is that they have something called softproofing. Softproofing allows us to see our image in CMYK, and we can draw our incredibly bright green and will look normal. And when we select colors, they will show the actual RGB color that's being picked. Now, if you're used to such a program, then you would think like, okay, you've got here in color management, you've got, yeah, here we've got softproofing options, so we can change everything, and we can put this to this, and we can change the gamut warning. I will explain what the gamut warning is later. And yes, and okay, and then we put this to gray. Yes, okay. We press OK, and nothing changes. The reason for this is that we kind of studied how people use softproofing and the workflow behind it, and we kind of realized that oftentimes softproofing is something that that needs to be configured per document. So what Krita does is that it saves the softproofing settings into the document. You can modify the active softproofing settings here. For example, we can change this to a different color model or a profile. We can change the gamut warning to gray, and you can change everything that you will need for proper softproofing. The unique one here is adaptation state. What it does is that it allows you to emulate the paper color. The reason why it's implemented like this is because LCMS understands it like this, and it has to do with the way how the ICC standard is implemented in LCMS. But this allows you to emulate the paper color when in absolute colorimetric. So now this gamut warning thing, you've probably wondering like, what is gamut warning? Gamut warning is out of gamut warnings. So if a color is out of gamut and thus gets manipulated by or gets deformed by the color selection, it will show it as this. It will show this gray gamut warning color that we've picked, and this is kind of useful for gradients. So I will now pick a different, where it will show you when the colors get clipped, is your official term, and then you can do some adjustments. You can do a color adjustment curve, No, turn red lower, and then it will fit inside the gamut. Now if you lower the red too much, then it becomes green, but that's a filter thing. Another thing we noticed is that, let's turn off softproofing, is that people were like, okay, but softproofing is quite difficult. So what you need to do is you need to make like a new copy of the current image, and then you need to softproof that copy, and then you need to compare the two, and then you only do your edits on this image, and then when you are done, you throw away your copy and you make a new copy and then turn softproofing on that. And the reason they were doing this was because they could not compare their original image and the softproofed image, and we were thinking like that's a bit over convoluted. So what we did is that, okay, we're going to remove this copy, and we're going to make a new view, same image, and we're going to tell them. What we did is that softproofing is toggled per view. And turn off out of gamut warnings. Softproofing is toggled per view. So if you add your colors here, they will get softproofed. Or they will get softproofed in the alternate view, and you can just edit your image here and make pretty things. This is already in Krita 3.0.1. Mostly because it was a bit easier to implement than the other thing. So you can already use this. Combined with the new color selector, you should be able to use this to really take advantage of Krita's wide-gamut editing capability, and you probably now understand why this was called making Krita ready for wide-gamut editing, because while we do have the architecture, we didn't have a lot of the necessary tools to really take advantage of that architecture yet. So you can really now take advantage of it and use your preferred color selector to paint images in either CMYK or in scene referred HDR colors, or in wide-gamut. A last thing that was in my Google Summer of Code project was also open raster support. It did not get implemented during the Google Summer of Code, but I currently have a branch where open raster support is being improved, so that's coming up as well. As a final note of warning, this isn't ported yet to the final selector, despite everything else, because this advanced color selector Docker is actually quite complicated, and I want to make sure that this version is implemented correctly, and that there's no bugs left with it anymore. There might still be bugs with it. And until that time, I'm leaving the advanced color selector alone, so that you always have like a fallback to go back to. Anyway, this was my Google Summer of Code project. It's going to be fully in 3.0.2, and it's going to be really exciting. I hope you really enjoy using these features, and yeah, I hope you enjoy them. See you later.